This video is about page 5 of the bonding notes packet. So this video is going to be talking about ionic bonds. A general rule of thumb that you can follow is that when a metal and a non-metal come together, they form an ionic bond. So what happens in an ionic bond? Essentially, metals tend to transfer electrons to nonmetals. We will get into representations, visualizing it, that will help you to understand this more. But if you think about the periodic trends and the properties of nonmetals versus metals, it makes sense that this is going to happen when you have a metal and a nonmetal coming together, okay? Nonmetals have high ionization energies. It's really hard to take away their electrons. They also have high electronegativities, which means they are really going to try to pull electrons towards themselves. Metals, on the other hand, are kind of the opposite. They have pretty low ionization energies, which means it's pretty easy to take away their electrons or remove them. And they also have pretty low electronegativity, okay? They aren't really pulling those electrons towards themselves. And when you mix those two things together, what happens is that the nonmetals get what they want by being able to steal an electron and fill their octet, and metals get what they want by being able to get rid of that 1 or 2 or 3 leftover valence electrons and being able to have their new full octet. So that's the gist of ionic bonds. When a metal and polyatomic ion bond, an ionic bond is going to form between them. Okay. However, you need to remember that the polyatomic ion itself, within that, for example, nitrate, NO3, there are covalent bonds happening inside of that polyatomic ion. So when I say that metals and polyatomic ions form ionic bonds, I'm talking about the metal bonding to the whole polyatomic ion. And so I failed to mention up here, with ionic bonds, there's an electrostatic attraction that occurs as a result of these metals transferring electrons to the nonmetals. Okay, so basically what happens is you have a positive charge resulting from that metal giving up its electron, and you have a negative charge resulting from that nonmetal taking on some more negative charge, and so there's that electrostatic attraction happening between the positive and the negative. All right, so there's lots of examples in your life where you use ionic bonds or see ionic bonds. The first would be table salt. If you salted your food today, congratulations, you used an ionic bond. That's NaCl or sodium chloride. If you've ever used baking soda when you're cooking or cleaning, that is an ionic bond happening right here between your polyatomic ion and then your cation right there. And finally, sodium hydroxide. We use this in labs very often. This is NaOH. And then here's a picture of an ionic solid. You'll see that you have some positively charged ions and some negatively charged ions right here, kind of forming this crystal lattice. And again, the reason why these guys are able to bond together is because of that electrostatic attraction, that positive and negative wanting to be together. So ionic bonds, they have high melting points. If you think about this, it's really, really, really hard to melt like table salt, if you've ever tried doing that, okay? Ionic bonds can conduct electric current when they're melted or dissolved in water. Again, if you really want to know why that happens, you can come talk to me. We covered that in AP. Most ionic solids are going to be crystalline or crystalline solids at room temperature, which means they're going to be in a crystal lattice structure, kind of like this picture. So if you think about salt, you ever looked at the little cubes, teeny tiny cube pieces of salt? That's what we're talking about. And then finally, they're brittle. They break pretty easy. One other thing you need to know is the ionic compounds. Their chemical formula is also known as a formula unit. So if you ever see me saying formula unit, I'm talking about an ionic compound.